we have a small triangle, WSO, and then a big triangle, KGO, that are overlapping and on top of each other. There are a bunch of measurements here. Let's transfer them into the figure. OG is this number here. OG is in the big triangle. Start at O and go all the way to G. That is 16.758. GK is 11.97. GK, that I can just put here, 11.97. There's nothing else near it, so no need for this scribble. KO, all right, now I need a scribble. I need to show that I have to go from K all the way over to O, and that is 10.773. Then WO is 5.13. WO is in the small triangle, so I'm going to switch colors so I can keep track of what's from the big and what's from the small. 5.13 is WO. That is this distance here. And then segment SW is parallel to segment GK. So let's put parallel, the parallel symbol. SW, put an arrow on this, is parallel to GK, which is this right here. So these parallel sides are being cut by a transversal right here. The transversal cuts through, it touches this side, and it forms an angle. And if you travel along that transversal, travel along, we get a matching angle in the same place, a corresponding angle, which has to be congruent to that one because these sides are parallel. And when you have parallel sides, the corresponding angles are congruent. This transversal cuts through and forms a different angle. So I'm going to put two arcs because it's not the same as that. If I travel along that transversal, I get a matching corresponding angle in the same place, which has to be congruent to that one because parallel sides that get cut by a transversal have matching angles that are congruent. Now the small triangle has angle O, the big triangle has angle O. Angle O is the same as itself, so I'm going to mark it with 3 arcs. The small triangle and the big triangle have all 3 pairs of angles congruent. That makes these triangles similar. Now I can name which triangle is similar to the other one. It doesn't matter how I name the first triangle. I'm going to start with the small and I'm going to go WSO. WSO. Now it does matter how I name the second. I need to match the parts. W has 1 arc, K has 1 arc, K goes with W. The next letter is S. S has 2 arcs. G has 2 arcs. G goes with S. The last letter is O. O has 3 arcs. And in the big triangle, O again has 3 arcs, so we put O. Now we have a sketch pad, and we're being shouted at to redraw both triangles facing the same way. Then we're going to put matching angle marks. Then we're going to put letters. And the last thing that happens is numbers. So first we redraw the triangles facing the same way. We're going to draw a small triangle. And then a big one that looks like it's facing the exact same way, but it's just a bigger version. Then we're going to put angle marks. We're going to put single, double, and triple marks in the same place of both triangles. Single and single. Double and double. I'm not looking at the original picture whatsoever while I do this. I'm just putting single, double, and triple marks in the same places because the point here is to draw 2 triangles with matching parts in the same places so it's easy to visually see top goes with top, side goes with side, bottom goes with bottom, left goes with left. They're drawn facing the same way. Now that these marks are here, we can put letters and then numbers. Small triangle, single arc, small triangle, single arc, that's W. So I'm going to put a W right here. The double arc in the small is called S. And the triple arc in the small is called O. For the big triangle, the single arc is called K. The double arc is called G. And the triple is called O. Finally, we'll put numbers. From O to G is 16.758. And I'm not just putting this on the bottom here because it's on the bottom there. I'm putting it on the bottom because from the triple to the double is 16.758. From the double to the single is 11.97. And then from the single to the triple is 10.773. Now in the small triangle, there's only one side we know. From the single to the triple, single to triple is 5.13. We don't know any other sides in the small, but that's what we're going to find out. We're going to find the measure of SW, which we'll call X. So let's put an X right there. And OS, there's OS, which we will call Y. These triangles are similar. That means their matching sides have to have the same proportion. We can use that to set up an equation. One ratio equals another ratio. If we want to set up the easiest equation to solve, let's put X in the numerator. X is for SW. We could go up to the names and see SW goes with KG, and then go to this information here and figure out what number to match to. But why do that when we have this beautiful crystal clear picture that shows X from the single to the double goes with the other single to the double, which is 11.97 in the same place because we drew it that way. So X goes with 11.97. X is from the small triangle over the big triangle. The next ratio needs to be the same way, small triangle over big triangle. I only know one number, so I have to use that in the numerator, 5.13. 5.13. What does that match with? Well, I can see it right here. From the single to the triple is on the left. From the single to the triple is on the left, so the 5.13 goes with 10.773. Now, X is being divided by something. I'm going to do the opposite and multiply by that something, 11.97. If I do that to the left, 11.97 divided by 11.97 is 1, and we have 1x, which is just x. And then to keep the equation balanced, we need to take the right side, whatever that was, put it here, and then also times it by 11.97. Whatever this mess gives you, that's the value of x. Copy it, paste it here, let the calculator do the work. X is 5.7. So x is 5.7. I'm going to put it here, and I'm also going to put it in this original figure. From W to S, that is 5.7. Then we have another side to find. We have to find y. We're going to use y for OS. Matching sides are proportional, so one ratio equals another ratio. To make an easier equation to solve, let's start with the variable. For OS, from the triple to the double, right here I can see triple to double in the same place, y matches with 16.758. So y over 16.758. Y is from the small triangle. We went small triangle over big triangle. The next ratio needs to be small triangle over big triangle. We have two numbers to choose from now. I'm just going to go with what I did the first time, 5.13. What does that match with? Well, I can see very clearly I drew it in the same place, 10.773. 10.773. Y is getting divided by something. Let's do the opposite. Multiplied by whatever that something is. 16.758. Do it to the left side, y is all alone. Do it to the right side, and you've got whatever that right side was now being multiplied by 16.758. That is the value of y. Take all of it, highlight it, copy it, paste it here. Let the calculator tell you that that is 7.98. So y is 7.98. That goes from O to S. From O to S is 7.98. So I'm going to label that and then kind of highlight it also. From O to S is 7.98. Now we have two more questions to answer. We need to find the measure of segment WK and find the measure of segment SG. WK is part of the big triangle. It's not the entire side. The entire side is 10.773. This whole red business here from K all the way to O is 10.773. If I want just this green part here, then I have to take the whole thing and remove, which means subtract, the blue. I have to subtract 5.13, and whatever's left is WK. It's 5.643. We got WK. Now how about SG? It's the same kind of thing. From S to G, that's a piece of the big triangle. It's not the whole side. The whole bottom side is 16.758. To get the green part from S to G, we'd have to take the whole thing and remove or subtract the blue, 7.98. That's it. We figured it all out. Bender's doing a happy dance for us.